Good morning, students. So we already saw how to use MATLAB online. So you can search MATLAB online here and click on start using MATLAB online. Once you click here, you will get MATLAB window like this, and you can click on open MATLAB online. I hope you all have already have your Somaya account linked with the MATLAB so that you can use it at home. Now here we are trying to look how to use Simulink. So you can see this Simulink button over here. Just click on it and you will get a new Simulink start page. So this is a Simulink start page which you will get, and within that we are interested to develop a new model. So we'll click on create a blank model. Now after clicking on create a blank model, you will get this blank window. Now in this window you can drag and drop different options. So these options are available in this library browser. So let me open it. Now you can see there are different libraries which are available. So currently I am going to use the Simulink library over here. So I will just go to commonly used blocks, and this is a constant block. You can just drag it and drop it in the system. So this is how easily you can get the required components. Now here we are interested to develop a system to show a pendulum or a simple pendulum and how it operates. So the pendulum is something like this, and the governing equation if we try to find out, it can be given as theta double dot plus gl is equal into sine theta is equal to 0. Here theta double dot is the second derivative of the angular position, that is angular acceleration, and theta is the angular acceleration itself. So for this system we will try to create a Simulink based model. So we will need a input for theta double dot, from which we will minus the gl sine theta, and that's how we can create the model. Now in this model typically our aim is to find out how the angular position can be displayed. So to create this model we will add different blocks, like the same way we added this constant block. So I need a few more blocks. Let me just get those blocks in the system. So I will need two constant blocks, one gain block, and typically I will need two integrators. Now what is the role of integrator? Integrator is to actually convert the signal by integrating the signal. So if we have acceleration, we can integrate it to get the velocity, and the velocity we can integrate it to get the displacement. So typically the integrator output, the input to the first integrator is nothing but your acceleration or alpha, which is being converted to omega, that is angular velocity. And in the second integrator, what is happening? Your angular velocity omega is getting converted into theta, that is angular displacement. So this is how we are getting the components. Now to show this angular displacement, we will use something called as a scope. Now scope gives us a good idea by showing the output graph, so that we can actually see how the output is occurring. Now one more thing we will need, this gain block is nothing but it is to show the minus of g by l. Here we are assuming mass to be unity, so m is 1. So this g by l block we need to multiply it with sine theta and minus it from this alpha. That is something we need to do. So for doing that we'll need a sine function. So instead of using just a simple sine function, we will use a trigonometric function in which we can actually add different functions if needed. So let me get the trigonometric function. Yeah, this one. Now actually we need to connect the theta to this sine. So we'll get sine theta, multiply it with g by l minus g by l, and add it to this alpha signal. So these two blocks we need to invert. So you can just right click on it, go to format, and you can flip the block, or you can click on it and press Ctrl I to flip it. After flipping, I will just connect this block over here. I'm sorry, I will need to just reconnect it, something like this. And this size block I will have to connect to GL so that it can multiply. And the second port I will take input from theta, multiply sine, provide to minus G by L, and minus it from the omega, minus from the integrator. Oh, sorry, alpha value. So now I will just double click on this gain and I will give it value of the G by L. So I'm assuming it to be somewhere around minus 0.9, something like this. 0.98, something like this. I will give the value. So the value is getting updated here. Yeah. And now if I try to simulate this model, it may not work because even though we have given the angular displacement and everything, we have not stated any initial position. So the body is initially at rest only. So there will be no motion as such. So to give the motion, we will give for this integrator, we will add a initial condition option. So let me just double click and set the initial condition to external. I will add this constant block. I will add this constant value. So this is the initial condition for the angular velocity, and for time being I will make it 0. And the second initial position I will use it for the second integrator. So let me just quickly update it. Again setting the external condition, and this external condition I'm connecting to this second constant block. This second constant block, and I'm making it 0.1. So the 0.1 radians is the initial condition which we have given, and with this if we try to simulate, we will see there will be output generated at the scope. You can see the simulation ready. That's why this ready is coming over here. So I can just double click on the scope. I can just double click on the scope to get the output. So this is the output which is generated by the system itself. So this is how I can simulate the simple pendulum with help of the MATLAB Simulink. So now you can try to add different mass to it and then complete the assignment to submit the model. Thank you.